Thanks. Hello. How's everyone doing? Show thumbs up if you're doing awesome, thumbs down if you're jet lagged and disoriented like me, or thumbs middle if you're just fine. So one of those three. Cool. That's what my yoga instructor likes to do before class. Show thumbs up, thumbs down, or so-so. It's a good exercise for your wrists. So my name is Isaac. I have been an Ember developer for 2 years. I'm still very new to web development. Show of hands. How many of you are also new to Ember, 2 years or less? Wow, please give them a round of applause for taking time to attend Ember Fest. Yeah. And once again, show of hands, please. How many of you are mentors to new developers? Well, this time I thank you from the bottom of my heart. I believe it's all of you, the mentors and the new developers, who will keep Ember strong and innovative as we move to the year 2020. That's just in 2 months. Can you believe that? Today I'll talk about two things that I love with passion: mathematics and writing tests. It's kind of funny. As an applied mathematician, I study fracture mechanics. It's the study of how things break. Now, as a web developer, I'm still studying how things break, especially on I-11 and Edge, the banes of our society. Joking aside, I want to talk about writing tests, especially for developers who are new to Ember like me, and for the mentors who are guiding them. I believe Ember gives new developers the power to feel productive, the power to feel good about themselves after work from day one. As a new developer, one of the things you can do is poke around the app and describe what you saw. That's exactly what writing tests is. The only question that remains is, how should you write tests? Are there best practices that you can follow? I'm here to tell you the answer is yes. Every one of you has the power to write tests like a mathematician. By the end of this talk, you will learn 5 simple rules I like to follow when I write tests. They are: number 1, if. 2, you use common everyday words. Number 3, write less with theorems on your terms. 4, all your bases belong to us. What does that mean? And last but not least, number 5, a picture is worth 1,000 words. I came up with these rules based on my experience of writing proofs in college and graduate school. See, when I was in uni, I wrote proofs that were horrendous, an abomination. I made plain wrong assumptions, the logic didn't follow, and oftentimes my proof worked for some cases, but not all like it's supposed to. Does that sound like you and your tests? In college, I actually hated writing proofs, and sometimes I hated myself because I wasn't good at it like all the other mathematicians. It wasn't until I entered graduate school when I had to study countless proofs day and night and had to write many in return that I began to see patterns, best practices, if you will, for writing proofs. And once I saw these patterns, each month I got better at writing proofs, and soon I was even able to teach others how to write theirs. When I look back upon this experience, I wish I had known sooner in college how to write proofs, because I'm sure I would have been fantastic at it. I wish I'd had someone, a mentor, to show me how. And that's why I give this talk today to you. If you are a new developer who perhaps feels inadequate when writing tests, I want you to know that you're not alone in how you feel. I was like you, and that you can get better with practice like I did. And if you're a mentor, I want you to think about what are some best practices that you can teach and how your mentees might feel when they write their tests. With that said, let's get this show started. Rule number 1, if, is about making good assumptions. When mathematicians write proofs, you'll be surprised. They're actually telling you a story. Mathematicians rely on conditional statements, also known as if-then statements, to tell you what happens to a character in the beginning and what happens to them at the end. If-then statements allow mathematicians to connect different scenes to tell one cohesive story. I think that's a powerful thought, that writing tests is nothing more than telling someone a story. When the user visited the sign-up page, they saw a form that is majestic. The user filled the form at ease, and the submit button was enabled. the user clicked on submit, and they're redirected to, whoa, dashboard. They're now on level 2, hoping to find the princess in yet another castle. Wouldn't it be awesome if your test spoke to you like that? Here's where things go wrong. To illustrate, I will share a personal fact. Yesterday was my birthday. Thank you, yeah. I turned 31, and I'm this close to midlife crisis. To cheer me up, I was hoping that we can do something special. We have about 200 people in this room. Mathematics tells us there should be about 16 other people born in October like me. Raise your hands, October people. Let's see. Well, a little fewer than I expected, but okay. Now the rest of you, will you please sing happy birthday for me and these wonderful friends of yours whom you haven't met until yesterday. I promise you, afterwards, you'll feel good about yourself. Are you ready? You have to make sure to sing aloud so the people who watch this video later know exactly what happened. On the count of 3, and by the way, born in October, can you raise your hands? I have some gifts for you. So on the count of 3, 1, 2, 3. Happy birthday to you. Yeah. Happy birthday to you. Happy birthday. Happy birthday. Thank you. Yeah. This is perfect. I was really worried that you wouldn't play along and I have to make this awkward transition to the next slide. This is perfect, thanks. So in the beginning, I mentioned that rule number 1 is about making good assumptions. On the surface, this test worked perfectly. I got personal, you sang happy birthday, and now you're happy, I hope. Well, I lied. Yesterday wasn't my birthday. So of course not, that's 1 out of 365 chance. Like, why would you believe that? I am 31 though, and I may or may not be close to a midlife crisis. As you can see, not all assumptions were correct, yet you were able to sing happy birthday and feel happy. This example, although it's contrived, illustrates a problem that you'll often face. You have to make assertions based on assumptions, but in reality, when your tests are running, not all of your assumptions may happen. And to make matters worse, the reason for that may not be obvious, especially if you're new to Ember. In my experience, there are 5 things that cause me to make wrong assumptions. I'll go over what they are and how Ember can help us solve these problems. Keep in mind that these reasons are not at all obvious, and they deal with advanced topics such as state transitions. So don't feel overwhelmed if any of these are new. What I want you to know is that when your tests fail, don't be discouraged. They are an opportunity to take a pause and ask yourself, are my assumptions correct? First, there are observers and computer properties. As your app grows, it becomes hard to ensure that these are triggered at the right time and that all of your dependencies are listed and up to date. Things are better in Octane thanks to async observers and track properties. Still, managing state is not an easy task and requires thoughtful design. Second is data. The form builder that I use heavily relies on observers and two-way bindings. And as a result, the data that I expect to have and what actually exists in Ember data store can be out of sync if I'm not careful. In general, when you're designing components, please use data down, actions up. And third is called unsettled state. Ember's tests run synchronously, one assertion after another. But Ember's test helpers aren't aware of all async operations that happen in your app. If you animate elements or read files, things that take time, you want to make sure that your app has settled before making assertions. You can use Ember's wait for and wait until helpers to do so. Fourth is leaky tests. They are a headache. Ideally, each of your tests runs in an isolated environment. Unfortunately, the assumptions made in one test can sneak into another if you're not careful with asyncs, global variables, mocks, and stubs. And as a result, whether one test passes starts to depend on another. To my knowledge, the only solution here is prevention. Ember QUnit can find async leakage, while Ember sign-on can prevent stub leakage. You can also use Ember exam to randomize test orders so they can identify leaks early, but that's it. And last but not least is permissions. As developers, we're used to writing code as an admin because we get to see all parts of the application. As a result, we may end up biasing our tests, thinking that the user does also. Please write tests for non-admins too. You can use nested modules to easily set up and group tests for admins and tests for non-admins. That was a lot. Let's all take a deep breath. So I've been practicing yoga since last December. In yoga, people practice ujjayi breath. You close your mouth and make a guttural sound in your throat like this. I swear, you'll find this soothing every time. Except if you're on a video call, forget to turn off your mic, and everyone hears you heaving. That happened to me in a meeting with the Ember learning team, and the person who had to point out was Tom Dale. Talk about first impressions, right? He was nice about it, though. Speaking of video calls, rule number 2 is about how to communicate with others. Remember that by writing tests, you are telling someone a story. You want to make sure that the other person understands you easily. You can do so by using common everyday words. Here, common means convention. It's something that many people agree to. And everyday means simple, something that many are familiar with. When mathematicians write proofs, they use everyday words such as continuous and zero to tell their stories. You'll be surprised that math proofs aren't always about numbers and complex equations. There are words, there are pictures, and there's always a story. Just like mathematicians, you can write tests with words that you use in your daily life. Thanks to add-ons like Ember test selectors, Ember page object, QUnitDOM and ChiDOM, your tests can be easily understood by other developers. Thanks, Isaac. Here's the other Isaac, by the way. Mathematicians also follow a common language. For example, the letter F often stands for a function, whereas brackets and parentheses indicate the domain of F, the input of the function. Thanks to standard notations, mathematicians easily understand each other, no matter where they come from. When writing tests, I recommend creating a standard that is both easy to remember and easy to type. For example, if you use Ember test selectors, always refer to links by data test link and buttons by data test button. If you want to check data, you can use the name data test field in both edit and view modes. You may have noticed that I've been using the label or ARIA label to identify the data test tags. And this practice of identifying elements by what's visible on the screen nicely complements accessibility-driven testing. This is something that add-ons like semantic test helpers are trying to solve. Rule number 3 is to write less with theorems and new terms. Mathematicians are very much like us developers. They love writing proofs that are short and dry. Don't repeat yourself. Remember this statement. Mathematicians can prove this with a single line. Use the intermediate value theorem. That's it. If they're really ambitious, they're just write IVT and call it a day. It's absurd, but a powerful idea. You can write short tests if you know that a part of your test is proven already. Short tests mean less code that you have to maintain later. That's a good thing. Mathematicians call what's already proven a theorem. We developers call it a test helper. Thanks to Ember's new testing API, writing a test helper is simple. You write an ordinary function, async in this case, to describe what the user does. Then you use that function in your test. Think of writing test helpers as extracting a part of your test code for reusability. Another test helper that I use every day is called authenticate. It assigns the user the right permissions in my test. Given these 2 examples, can you now think of ways to refactor your test code? There is another way for mathematicians to write less. It's to create a new term to describe an idea that happens over and over in different contexts. For example, you will see continuous functions everywhere. In linear algebra, calculus, topology, optimization, and machine learning. To avoid having to write continuous each time, mathematicians introduced the C notation. Now they can write less, yet precisely tell their stories. When you write tests, you'll find assertions that happen over and over. But Q in a DOM or Chai DOM doesn't provide the API out of the box. It simply can't satisfy all business logic. Just a sec. But not to worry, just like mathematicians who create new terms, you can create custom assertions. A custom assertion, like test helpers, is just a function. You can define it however you like. Here, the assertion is enabled hides the complexity of checking a button state. It's a simple example, but you can definitely get more ambitious by checking complex data structures, such as tables and D3 visualizations, arrays and trees. By creating good abstractions like this, you get to enjoy two benefits. One, you can write short, meaningful tests. Again, short means maintainable. And two, others can write similar tests without having to know the technical details on day one. They get to be productive thanks to you. Rule number 4, all your bases belong to us. When mathematicians write proofs, they have to cover all possible cases, and often that's an infinite amount. With tests, however, you can't cover infinite cases because your test would run forever. But instead, you can find a basis to guarantee that your app works almost always in the fewest number of tests possible. So let me explain what a basis is. In mathematics, a basis refers to independent vectors that span the entire space. The keywords are independent and span. Span means to cover, like test coverage. You probably haven't heard of the term basis, but I bet that you're already familiar with the idea. Latitude and longitude are an example of a basis. These coordinates are independent, and for every combination, you can find a unique location in space, which is infinite. For example, 5512 takes you to Copenhagen, and 30-97 to Austin, where I come from. Just two numbers, 3 counting elevation to describe the infinite space. RGB scheme is another example. There are infinitely many colors, but each color is a unique combination of red, green, and blue, 3 numbers. For us, a basis means finding a small number of tests that can be considered building blocks. If we can prove that our building blocks work, then mathematics tells us that our app works no matter what the user does. That's a powerful statement. Let's make this idea of a basis more concrete by looking at 3 examples. First one, suppose you're designing this page where the user sees data and can take 5 different actions: create, edit, delete, clone, and import. You want to prove that the table will always show the right data. The problem is there are infinitely many sequences of actions that the user can take. For example, they can create a record, then delete another. They can also do import, edit, then clone. These are just 2 examples out of infinitely many. There's no way you can write a test for each and every possible sequence of actions. But what if instead you guarantee that each action returns the user to the right state? When the user first visits the page, everything works and they're happy. When the user takes an action, you make sure that they return to the happy state where everything works. And that way, when the user exits the page, you know that everything is correct. The beauty of this approach is that now you only have to consider 5 test cases, 1 for each action. You can be confident that the app is in the right state when the user enters and exits the page. Example 2. Here is a component that I created to visualize LDOF filters. You can enter a filter to understand its logical structure and edit the expression with confidence. I can also find errors and help you fix them. There are infinitely many expressions that an LDOF filter can take, but you can always break it down into these 4 basic types and 3 operations, 7 vectors to check. And the last example is a D3 component for visualizing a DSL, domain-specific language. You can interact with this graph to actually write the code in reverse. Again, there are infinitely many programs that you can write, but the graph always boils down to a few basic types. It's how I know that my D3 visualization is correct. So up until now, you learned several strategies to level up your testing. You have to make good assumptions, choose the right words, write short tests, and break down large problems into small ones. And I have to ask, are you as overwhelmed as I? I simply had to read my script. You actually had to listen and learn, which is infinitely worse. Well, the final rule in yoga terms is shavasana. It's a moment to wind down, reflect on your journey, and wake up re-energized. One tragic thing about proofs and tests is that they ask us to be perfect. The things that we build are ambitious and complex, but if you make one mistake, a proof gets rejected by the community, while an app faces vocal customers. It's a terrible feeling to have, to constantly worry whether our tests and our app are good enough. The last rule that I want to share asks you to let go of your worries and be okay with not being perfect. What you go for instead is incremental change. Each day, each sprint even, you work on writing better tests. The most important thing above all is to have fun, to enjoy what you do. Suppose you're designing a component that is complex and you're not sure how to write tests for it. Start out with the most simple test, assert okay, true. Even this one line offers valuable information, namely that your component won't blow up just by existing in your app. That's a good thing to guarantee. Similarly, if you're working on this complex page, you don't have to write thorough application tests right away. You can use Percy or Backstop to take visual snapshots while you gradually introduce written tests. It sounds kind of counterintuitive, right? The visual snapshots are as good as written tests. Let's take a look at what mathematicians do one last time. I'll bet that before, this meant very little to you because you didn't understand the words. Am I right? Here's the same statement in drawing. From this picture, it's clear that if my function is continuous, is positive on one end and negative on the other, it must be equal to 0 somewhere in between. That's all the statement said. And furthermore, from this picture, we can imagine a powerful technique called bisection method. It's how get bisect works. Let me show you one more example to illustrate that pictures are powerful. I'll prove to you that there's many numbers between 0 and 1. This small little piece is there between minus infinity and plus infinity, all numbers. It's a mind-blowing fact about infinity that a part can have the same size as the whole. This green line represents all numbers between 0 and 1. Each number is a point on the line. From the center, I'm going to draw a semicircle. These dotted lines show that there are as many points on the green line as there are on the blue line. Do you agree with that? From the center to each point in the circle, I can draw a straight line and stop at the bottom. Just like before, these dotted lines show that there are as many points on the blue line as there are on the bottom green line. And notice that the bottom green line goes to infinity in both directions. Therefore, you can find as many numbers between 0 and 1 as you can between minus infinity and infinity. How's that for a slice of fried gold? Yeah. I really want to nail that down, the last line that I said, but I'm not Scottish. It's hard for me to do like really high-pitched voice. You just have to imagine Simon Pegg and Nick Frost about to kill zombies and save the world. And if you have no idea what I'm talking about, I'm going to assign you homework. You have to watch Shaun of the Dead. Well, I guess when you get back home. So let's go over the rules just once more. Number 1, writing tests is nothing more than telling someone a story. You describe what happens to a character in the beginning and what happens to them at the end. Please check whether your assumptions are met in your tests. 2, to tell stories effectively, you want to use words that others can easily understand. Come up with a convention that you and your team would love to use every day. 3, thanks to Ember's new testing API, you can write test helpers and custom assertions to write less code. You can write short, meaningful tests and help others be productive. Number 4, when you face a large problem, see if you can break it down into smaller ones. In particular, if you find independent vectors that span the entire problem, you can guarantee that your app works almost always. And finally, number 5, it's okay not to be perfect. Be happy with who you are today and whom you can be tomorrow. The most important thing above all is to have fun, to enjoy writing tests. It's time for me to start running and say goodbye for a little while. And I know you're going to miss me, so I'll leave you with this. No, not an MCR song. It's a quote that I love most dearly. To me, this quote is about continuous learning and not giving up when things are hard. It's by T.S. Eliot, and it goes like this. We shall not cease from exploration, and the end of all our exploring will be to arrive where we started, another place for the first time. Well, thank you very much for listening. If you'd like to know more about me, please reach out on LinkedIn and Discord. Have a great afternoon.